very much. Yes, I was a former EPSRC-sponsored PhD student, so reaching out to all you my fellow sufferers. Just going to talk 10 minutes on Geoff Hewitt. I first knew Geoff Hewitt when I was an undergraduate in the Chem Eng department at Imperial College in the late 90s. Like most undergraduates, I was really impressed by his ability to explain complicated scientific phenomena and their application in the real engineering problems. He clearly had lots of experience, was amazingly organised, and his office didn't look like that, but it was very well organised, and had a great sense of humour. I learned a lot about process heat transfer, multi-phase flow, and I learned a lot about teaching as well from him. He was clearly a busy man. He often said that he was time bankrupt. There weren't enough hours in the day for him. However, he still managed to find time to advise young engineers and help them via his many industrial contacts. That meant a lot to many students, and well, I think of Geoff, I look back at being his PhD student and our PhD family, but actually there were a lot of undergraduate chemical engineers who think very fondly of him as well. It was clear that he was equally respected in academia as well as out there in industry. That was because he spent 30 years at the Atomic Energy Authority in Harwell before coming to Imperial. In Harwell he had the opportunity to do groundbreaking research as well as consultancy and business development. His experimental and modelling work, particularly in the field of annular flow, disturbance waves and burnout, were pioneering, and he wrote a book on the subject which is still in use today. He wrote and edited several more books on nuclear engineering, process heat transfer, and the Encyclopedia of Heat Mass Transfer, and hundreds of well-respected papers. But on the industry side, he was the founder of and head of the Heat Transfer and Fluid Flow Services, HTFS, which was later acquired by Aspen Tech, and he was the head of, when he was the head of Thermal Hydraulics Division, he commissioned the development of a commercial CFD simulator called Flow 3D at the time, but later changed its name to CFX, which was since been acquired by ANSYS, the CFD manufacturer company. He knew more about knew more than most about the practical applications of the science that fascinated him so much. So in the last year of my degree, I investigated my options to do a PhD at Imperial. You know, Dr. Watson had a kind of nice ring to it. I don't know where I got that idea from. There were a couple of options to me, but a friend of mine, gave me a great piece of advice, which is you should pick the supervisor and not the subject. I see a lot of PhD students looking at each other going, yeah, that's where I went wrong. Sorry about it, too late for you, but maybe you want to pass that advice on to somebody else. Okay. With that, I knew I had to pick Geoff. Anyone that made something as boring as multi-phase flow seem not only interesting, but critical to the development of our species had to be the right supervisor for me, even if I had to do multi-phase flow. I'm sure Geoff will forgive me for saying that. You realise I'm saying that as a joke. But, and as he once said, there are no interesting things, there are only interested people. During my PhD, I was impressed with Geoff's method for organisation of the various PhD projects. It centred around a system of monthly minutes that he would eloquently dictate into his trusty dictaphone. All of his ex-students will remember the reports on the actions agreed at the previous meeting where that followed was going on. Where we all had to type up afterwards. The only downside of the system was the sickly feeling the hours before each monthly meeting, feeling bad that I only managed to generate one measly data point from the rig, when I confidently promised that I'd generate hundreds in the previous meeting. However, it was worth that ill feeling, because in the meeting you get an injection of enthusiasm from Geoff, and he'd be flipping reports out and papers and saying, oh yes, you're showing the right trend as this paper over here. Very very interesting, Martin. We're doing really well done. So I'd go into the meeting feeling like a miserable wretch and come out full of fire, feeling that what I was doing was cutting edge. It was hard, yes, but the rewards would be glorious. So, yes, worth it. Absolutely worth it. So I would always be grateful to Geoff for giving me the opportunity to work in his Imperial College family. It is something that set me up for life. After my PhD, I went into the upstream oil and gas industry, and in 2012 I was lucky enough to work with Geoff again on the Deepwater Horizon Volume to Sea litigation. Those of you who read about it, maybe you've seen the Mark Wahlberg movie, will know the scale of that accident in the Gulf of Mexico. It's the largest oil spill in the US, with 11 people who died during the explosion. BP lawyers employed my company, FISA, to investigate the US government's estimate of the volume of oil released to the sea. One of the $1 billion fines that BP would need to pay would be proportional to the volume of oil released. It was agreed by the judge. So it's important to get it right, and the US government didn't. Long story short. Most of our contribution was in modelling the whole incident in our simulator, Maximus, to see how much oil came out throughout the whole incident. Geoff was also retained by the BP lawyers. His main role was to act as a sounding board for us, and in the words of BP's lawyers, to keep us honest. And they were very fun to have him there, but also very useful to have him there as well. Because it was just like old times again. But this time it was in my backyard. You know, I'm no longer a fresh-faced PhD student. You know, I've been working in this industry for quite a while now, Geoff. Thank you very much. I think I know a little something about this. So when Geoff asked me to do a particularly annoying hand calculation for the next meeting, I didn't think it was necessary. I still did it out of respect for the old man. Though I left them until the very last minute before he arrived for the next meeting. Yeah, silly old Geoff. Does he realise how many worlds I've simulated in my life? If I thought for 1 minute that, oh, hang on, he's right. Again, when will I ever learn, Geoff? Just do what you told Martin. So it was very a great fun time as well. Geoff was a fellow of the Royal Society, fellow of the Royal Academy of Engineering and the US Academy of Engineering. He's been the president of the Institute of Chemical Engineers and the Heat Transfer Society, and in 2007 was awarded the Global Energy Prize by Vladimir Putin. It's a great photo of him being handed this prize by Vladimir Putin. It's on the internet. It actually looks like someone said. It actually looks like Geoff is giving Vladimir the prize. So he's so happy as well. But of all of his great qualifications and abilities, there was one that all who have met him will remember the most. He was a true gentleman. It was a pleasure to be around, a recharging point for enthusiasm, and an honour to have known him. So, thank you, Geoff. So, one of my unofficial actions at my monthly PhD meetings was to tell him a joke. That didn't get minuted, unfortunately, because I can't remember them. I do remember one that we both liked, and I think it's appropriate to this particular conference. Apologies if you've heard it before. It was new in the 90s. A data scientist, a CFD modeler, and a physicist were each asked to write a proposal for a research project to build a model to predict horse races. The data scientists said that they could train an artificial neural network using all the data available from races that have already been run. It would cost about $100,000 to build, and is expected to be 30% accurate, provided the next race was exactly the same as the race before. Their proposal was rejected. The CFD modeler said he could develop a high-performance computing system that directly models details such as the turbulence eddies around the horse and the effect of mud on the forces on that the hooves exchange with the ground. It would cost $10 million to develop, take a year to build, and 3 months to run each simulation. The quantitative accuracy of the results might not be particularly good, but it would give great insight into the flow mechanisms. Their proposal was rejected. The physicist's proposal was to build an analytical model of the whole system, and it costed just $10,000. It would be 99% accurate and would solve effectively instantaneously. The physicist's proposal was accepted with great enthusiasm, and he was asked to kick off the project straight away. Right then, said the physicist, first we'll assume that the horses are perfect spheres. Yeah. Thank you very much. Thank you, Geoff.